the limit at infinity because of simply rewriting the function like this tells me that this is the power that dictates. This is too small at infinity, so the answer is infinity. Is this okay with everyone so far? And when I see this product, I immediately plug in 0 to find the y-intercept, and then when I set f of x equal to 0, I get two solutions. One from here, one from here. It's a product. Okay, so now when I differentiate, I will use this. So then f prime equals 3/2 x to 3/2 minus 1, which is 1/2, and minus 3/2 x to 1/2 minus 1, which is negative 1/2. Oh, look at that. Nice pick. Okay, so now f prime of x, I will factor out 3/2, and of course x to the smallest power, x to negative 1/2. Now let's see. From 1/2, I subtract negative 1/2, and I get power 1. From x to negative 1/2, I subtract, so I get negative 1. This is basically x3, x minus 1, divided by 2, the square of x. Undefined at x, so I don't forget. That's one thing that I have to write immediately, that the function, the derivative, and also it's the second derivative will be undefined there. And it is a critical number. And the other critical number is x equals 1. I will study the sign of the derivative, but not the sign of this, because it's always positive. So to the left of 1 is negative, to the right of 1 is positive. I plug in the function 1 for this point, for this y value when x is 1. So 1 minus 3, negative 2. Now the moment of truth, what I like to call it. What does that mean? These two rows, if they don't work well together, then I'll say, I have to go back to the drawing board. So, from 0 to negative 2, true. From negative 2 to 0, yes, that's correct. From 0 to infinity, yes, that's correct. Good. So now I'm going to look at the second derivative. Obviously, this is a local min, for sure. Why? This is a critical number. The derivative is 0, and it changes sign from negative to positive. So this must be a local minimum. So now let's look at the second derivative. Very nice problem you chose. I'm happy I didn't choose it, because I normally don't choose nice problems. I don't know why. Okay, so where is my first derivative is this. So I'm going to use this. So the second derivative, let me put it here. So I can leave 3/2 outside, waiting patiently. So 1/2 x to 1/2 minus 1, negative 1/2. And then 3/2 is outside, but I bring negative 1/2, so now it's positive 1/2, x to negative 1/2 minus 1, which is negative 3/2. Okay, I will factor out 1/2, so it becomes 3/4, and the smallest power, which is negative 3/2. Okay, negative 1/2, but minus negative 3/2 is 2/2. Plus, this is completely out, 1/2 is completely out, everything is out. So this is 3 x plus 1 over 4, the square root of x to the third. And you can say, oh, that's so nice, x equals negative 1. No. So the second derivative cannot be 0. Why no? Negative 1 is here. It's not in the domain. So then all this is positive because x is positive, and x plus 1 is positive because the intercept of that, the x-intercept of that is at -1. So to the right-hand side will be all is positive. So this is done, no inflection point. The function has to open up at all times. Now we're ready. That's it. Not symmetric, of course. A function defined on 0 to infinity cannot be symmetric. So I'm going to write that down. Not odd or even. Okay, so now let's graph. There is no point in showing anything to the left. And I only have 0, 1, and 3. So let me use the different color. So 0, 0, 1, -2, and 3, 0. So it's coming from the origin down to -1, 2, crossing the x-axis, going up to infinity, opening up at all times. So this is the function x minus 3, the square root of x. Quite a neat function. Not a lot of calculations. Everything worked out smoothly. Good pick.